Logarithms are used a lot in biology, but the most common area that they're used in is to actually describe pH. And you'll probably already know that pH is a way to measure how acid a particular solution is. And in fact, when you have a pH number which is low, for example, pH 2, which is about the pH of our gastric juices in our stomach, or things like lemon juice, this means that the number is very low, but the amount of acid in the solution is very high. So I'll say high acidity. The converse is true, that solutions which have low amounts of acidity, such as pH 14, that's something like your dishwashing solution or bleach, for instance. We say that has very low acidity. So be careful when you're describing the relationship between acidity and pH, because the higher the number, the lower the acidity, and vice versa. Now, the thing about the pH scale is it's actually a logarithmic scale. And most of you know that it's centred on pH 7 here, which is termed neutral pH. And it basically spans from about pH 1 to pH 14. This is high acid, which is described as the concentration of hydrogen ions, and this is low hydrogen ions at high pH. In between here is a scale. And this scale has a huge dynamic range. This scale is a logarithmic scale, so when I move one pH unit away from this position here, we are actually increasing the concentration of hydrogen ions by 10-fold. So if you hear that a solution it's been adjusted from pH 7 to pH 6, that may not sound like a lot of difference in acidity. However, it's actually a 10-fold increase in acidity. Likewise, if you go to pH 5 here, you're actually increasing the acidity, because this is a logarithmic scale, 100-fold. And then if we went to pH 4 here, 1,000-fold. So pH scale, though these look like, if you like, even increments, they're not. They're a logarithmic scale, meaning that every movement of one unit represents a 10-fold change in acidity. If you're moving in this direction, it's an increase in the hydrogen ion concentration. Moving in this direction here is a decrease in the hydrogen ion concentration. So this is really important to appreciate. If you think about a human body, which usually is about pH 4, our body doesn't move very far away from pH 4, but because if we move very much further, we would be having huge changes in the acidity that our cells are exposed to, and as a consequence, those cells will be under stress and ultimately die.